data sharing and collaboration. Just to share one fact about it, what is this and why this is a challenge? If assume that if I am working on NGS data of 100 samples or 200 samples for a cancer, and if tomorrow any person is basically want to work exactly where I stopped, I started working with cancer data, I stopped by getting the mutations, and the person wants to start from mutations and he want to get the biomarker. So in this case, if he want, he can use my data, right? So I can share the data or I can collab the data instead of starting everything from scratch. So this word we call in our language data marketplace. Okay, we call it in our language as data marketplace. It means one data can be reused by other person. It can be either sellable, it can be either purchasable, or it can be either shareable with the ethical concerns. Okay, so now we understood all those things, right? And what is the main concern if I come back once? Okay, so the main concern is computational part, isn't it? The main concern of doing NGS and everyone, it's not only NGS, wherever we're working on the bioinformatics side, it's basically the computational part, right? More the computational, the resources and all those things, right? How well we can use a resource, how better we can use the computational things basically, okay? So keeping all those things, there are many variety of way that we can write a pipeline or we can develop a pipeline. I'll come back to my slides once again. Okay, so there is many variety of way basically where we can write a pipeline or where we can develop a pipeline. It's not exactly that if you'll say that, hey, if you give me a 32 GB of RAM of a laptop, I cannot work on whole exome analysis. Sorry to say, in 16 GB RAM of laptop also, you can work end-to-end of full genome analysis, end-to-end with a real data set. While running the pipeline, have you ever checked that the pipeline is actually taking everything, every CPU available or every RAM available in your laptop, or it is taking almost a portion? There is a lot of things you can scalable it actually. Okay, so when we talk about the word scaling, now some computational science, some engineering science comes inside this. And very recently on 2021, there is a publication which is available in Nature Methods, and they mention very clearly reproducible, scalable, and shareable analysis pipelines with bioinformatics workflow managers. So they talk about workflow managers. Okay, so before going to this workflow managers, I know if I go directly to the workflow managers, you will be again having a lot of brainstorming basically in your head. Okay, before going directly to the workflow managers, let me say you the pipeline engineering practices. Okay, let me say you the pipeline engineering practices. So when we talk about pipeline engineering practices, okay, so now the main ambition or the main motto is basically developing a whole exome analysis pipeline. Okay, developing a whole in a 64 GB RAM of computer or cluster or HPC or CPU, whatever is available, right? Right. This is the main aim. This is the main goal. You're working with an academic organization or you're working with a corporate basically, and this is the main thing that you have to do. This is what is asked to you. So earlier, before 8 or 10 years, what people were doing actually, before 8, 10, 12 years, they were installing each tools needed for whole exome analysis pipeline. Okay, whole exome analysis pipeline. They're installing each and every tools that is needed. Okay, as in my installation of tools basically took for them 4 days. For some person it may take 7 days. For some person it may take 11 days. But in some person it may take 2 days, depending on how better they are in installation, right? How better they are in their knowledge, isn't it? Now the next is, once you complete the installation, what next you are going to do? You are going to test it, whether the tools are working fine or not. Okay, so this testing of tools, this basically took at least assume 5 to 6, 7 days or something like this. Now what you're going to do next? You found that all tools are working. Now what next you're going to do? Here basically we're going to write a pipeline, right? Write a pipeline. And what is a pipeline? We always say pipeline. What is a pipeline? Anything which have multiple process. First, run this, second run this, third run this, fourth run this, fifth run this, sixth, I got the output. So this each and everything is a process. Now, if I put everything, every process in one file, in one script, in one programming file, either it can be on R or Python or basically Linux programming, which we call as shell scripting, right? So whatever we put basically, now this is called as one pipeline, right? So what it will happen is we'll just run it. It will run all the process for us and it will give the output. Only we need to feed data. Only we need to give data, isn't it? So this entire thing, and assume like for developing this pipeline also, it took some days for me, 10, 12 days. So if I'll show you, this is 10, 12 days, this is a 5, 6 days, again, this is some number of days. You spend almost 30 days basically for this solution, right? Okay, you spend 30 days. Now after a few months, basically, someone else is basically asking you, you know, to write the pipeline once again. Are you going to spend the same 30 days? So this type of engineering work used to happen before some years ago. Okay, then what happened? Then the second engineering work basically, or the advanced engineering work came to market is using Docker and containers. What do you mean by Docker and container? You have installed all these tools, right? If you remember, you have installed all these tools, right? So what you can do is you can install all these tools in an environment. Assume that your name is XYZ. So what you did, you created a virtual environment. You created a virtual environment using Python or using R programming or Shell, whatever it is. Okay. And the name of the virtual environment is XYZ. And in that XYZ, basically what you did, you basically installed all tools and you saved it. Now next what is going to happen, if anyone is going to ask you to write a pipeline, you don't need to install all these tools or entire things, right? What you can do is you have to load the environment that you created here and you have to develop the script and run it. That's all. So this is again going to certainly take a little less time, isn't it? Again, this is taking a little less time. Now what happened? Last 6 to 7 years, what practice is going on? You can do all those things. Okay, using this Docker and container solutions, you can do all those things. Also with that, you have to use CWL and YAML programming language. Again, CWL and YAML is not that difficult as like R or shell scripting, etc. Okay, and again, I am not saying that it is not that. Kind of, like everyone knows also, but this is the logic of using CWL and YAML. So what is this? This is as very similar like HTML. If anyone of you know what is HTML, this is very similar like HTML. So what we are going to do, you are going to have an environment, right? If you remember that this is an environment, right? I went to GitHub. On GitHub, I searched DNSSEC pipeline for whole exome analysis. I got it. I bring the pipeline and using CWL, what I did, I quoted the pipeline. It means the pipeline that I got basically from GitHub actually, the pipeline should have multiple steps, right? So for each and every step, I created one parameter, basically. I created one variable using CWL. Now, when I'm going to run the pipeline, there is one file known as YAML. This file will ask me parameters. What is this parameters? For example, if you know, for example, let us check once how a DNSSEC pipeline looks like, okay, before going to that side. Okay, so it is basically talking about each and every steps that is present in a DNA pipeline. Okay, right. So it said me the steps till data visualization, data interpretation.